All right, so let's go ahead and let's take a look at solving these by substitution. So when it says substitution, other than in 4-5, which we'll get to that in a second, I forgot to change the directions for 4-5. But essentially, I don't care how you solve the system on a quiz or on a test. I don't care which method you guys use. I would just highly recommend not using graphing. That would be the only method I kind of would not want you to use unless I specifically ask you to do so. Okay, now when I do substitution, the one thing if I looked at my top equation here and I tried to isolate one of the variables, I think I would be really sad because I'm going to end up with a fraction. And so if I can at all avoid fractions, like I'm going to try to avoid fractions. So I am not going to look at isolating my variable in my top equation. I'm going to look at it in my bottom equation because, and specifically the reason why, my y has a coefficient of 1. So the number in front of y is 1. And so if I were to get y by itself, I don't end up with any fractions. So I'm going to take this equation, I'm going to make y by itself by subtracting 3x from both sides. So then what I end up with, and I didn't need that arrow, what I end up with is 18 minus 3x is equal to y. Now I can take this equation and plug it into my top equation and solve for x. So I have 4x is equal to 3 times 18 minus 3x minus 2. So again, this is the whole reason why we did solving equations to start off with, is you're going to have to distribute. And again, if you can't do the arithmetic, horizontally, then stack them. So this is 4, 2, so this is 54. So 54, and then minus 9x minus 2. So then I get 4x is equal to 52 minus 9x. So I add 9x to both sides. And I'm going to get 13x is equal to 52. Divide both sides by 13. And I get x is equal to 4. Random fact. So when I do this, there's 52 cards in a deck. And there are 4 different suits in a card deck. Each suit has 13 cards. So that's how I always remember what 52 divided by 13 is because of a deck of cards. Okay, that's a complete random fact. Okay, so when I have my x equals 4, what I can do is I can plug it into the top equation, I can plug it into the bottom equation, or I can plug it into the one I isolated. Plugging it into the one that I isolated is far easier than any of the other ones. So not like I want to say let's be lazy, but let's be efficient with our time. So I'm going to go ahead, I'm going to plug in my 4 into my x into my bottom equation. And so then I get y is equal to 18 minus 12. So y is equal to 6. I want these in coordinate points. Oops, as I put the wrong coordinate there. I want these in coordinate point form. I don't want them just as an x equals and a y equals, because it's very important to me that you understand that this is the intersection of two equations, and they are an intersection at a coordinate point. And so it's really important for me that you guys understand that. When it comes to the word problems, I don't care if you write them as coordinate points. I actually prefer that you probably don't, unless I prefer that you answer the question. And so there's a certain, thing that represents X and a certain thing that represents Y. So I'd actually prefer in word problem situations for you to not write it as a coordinate point. But we'll get there. We're not dealing with any words just yet. Okay, so now when I look at my 2 equations here, and I was just going to start number 2 instead of going to number 3. But again, pick the one that has the coefficient of 1. So pick the one that has the 1 in front of the variable. This one is super nice to you, or super nice to me when I'm creating this video. I'd made one of the variables already isolated. So I'm going to go ahead and I'm going to plug in 4y in for my x into my bottom equation. So I get 12y minus y is equal to 70. So I get 13y is equal to 70. Divide both sides by 13. And let's see, I don't think 13 times 4 we just talked about was 52. Add another 13 and I get 65. So I'm not going to get 70. So y is equal to 70 over 13. And then I'm going to go ahead and I'm going to plug in into my x is equal to 4y. So then x is equal to 4 times 70 over 13. So then I get 280 over 13. So my coordinate point is 280 over 13, comma 70 over 13. Oops. Okay. Question 5, already isolated. Yes. Looking good today. All right, 4x minus 2 times 2x plus 1 is equal to 6. So I took my top equation and I plugged it into my bottom equation. So I get 4x minus 4x, minus 2 is equal to 6. 4x minus 4x is no x's. So I get negative 2 is equal to 6, which is not true ever. So this is no solution. If I would have gotten that the numbers were actually equal so that this was a true statement, then I would have had infinitely many solutions. Okay? All right, and that's it for this lesson.